Assalamualaikum. So today our group will present about the heat transfer analysis of a flat plate solar water heating system. So this is our team for this group assignment. For the objective, to use number one, to use tools like SolidWorks or ANSYS Fluent to evaluate the heat transfer mechanism in a solar collector and compare the outcome to theoretical calculations. Number two, to comprehend and use radiation convection and conduction in the framework of a sustainable ecosystem. So for diagram and illustration, we have a part, casing, insulation, pipe, flat plate, and cover. And we have a dimension and the material. So for the first one is a casing. The dimension is a 1650 times 1000 and the material is a aluminium. For insulation, the dimension is a 1600 times 900 and the material is a polyethylene high density. And the pipe, the dimension is 7800 and the diameter for pipe is a 50 millimeter and the material we use is a copper. For flat plate, the dimension is a 1600 times 900 and the material is a copper. And last, the cover, the dimension is a 1650 times 1000 and the material is a glass.
Okay, simulation setup. Step 1. Launch workbench and sys. Select fluid flow and drag to the right side of the project schematic. Right-click to the geometry, import file geometry and select the file. Next. Step 2. Mesh the sketching of geometry. Double-click the mesh until go to matching properties. Right-click to mesh and go to insert. To do the method and select the plane of the tube. Method selection, choose a tetrahedrons. Select the plane to insert the input, output, and wall at the name selections. Next.
So for step 3, location simulation. Location for performing simulation is chosen as Jalan Convention Melaka International Trade Center, 75450 Ayaka Road, Melaka. The coordinates for the location are 2.2710 degree north and the longitude is 102.2876 degree east. Area receives enough sun radiation to make it a suitable place for simulation. For the step 4, assign boundary types and parameters. Click the inlet at boundary conditions and select the type is velocity inlet. For the outlet, select the type is pressure outlet. Double click the wall and select the mix to insert the heat transfer coefficient is 50 watt over m square and wall thickness is 0.01 meter. Material name change to copper and apply. And table below is material for the boundary conditions, which are copper, aluminium, glass, insulation, and water. And each material have their own density, specific heat, thermal conductivity as shown in the table.
Step 5, determine the control and plane axis. Open the SCFT post to do the control and the plane axis. Select the control and choose the domains is or domains and location. Select the plane 1. For variable, select the temperature and range. Choose the local. Number of control for this simulation is 110. Choose the plane and select all domains. For the method, choose YZ plane and distance for the plane is 225 minus 225 millimeter.
The graph shows that the temperature distribution along a part of pipe in a solar water heater with distance plot against the temperature. The linear straight line equation describes the linear relationship between distance along a part of pipe and water temperature. The temperature range is within 309 Kelvin to 298 Kelvin. This shows that the pipe is absorbing the solar energy and heating the water as it flows. The heat conduction is related to the temperature difference. The experimental temperature difference is 11 degrees Celsius, which is 10% higher than the theoretical temperature difference is 10 degrees Celsius. Q conduction increase within 10% lead to a result around 186.062 times 10 power of 3 watt to 204.668 times 10 power of 3 watt. The convection heat transfer is also similar on conduction, which is the heat transfer is related to the temperature difference. The convection heat transfer has difference only 1 degree Celsius, but the effect on convection heat transfer is increased between 791 watt to 870.1 watt. This shows how sensitive the heat transfer is towards the temperature gradients, and the accuracy of temperature measurement are crucial in both the experimental and theoretical results. So the discussion, flat plate and pipe use material copper because high thermal conductivity for transfer the heat from sunlight to water. Copper has corrosion resistance for long lifespan. Aluminium used for casing because average conductivity to help dissipate excess heat from the collector to prevent the casing from overheating. Aluminium has low density to reduce structural load, makes it ideal for rooftop installation. Polyethylene, high density for insulation, has low thermal conductivity to reduce heat loss from the collector and pipe. Polyethylene high density has high specific heat to keep heat for longer periods. Glass used for cover, high specific heat to maintain stable temperature. Glass also has low conductivity to reduce heat loss while allowing sunlight to pass.
Conclusion, the analysis show that the solar water heater transfer heat through conduction and convection. Theoretical result match well with NC simulation, confirming the system's efficiency. Copper pipe and insulation help reduce heat loss. The simulation show good temperature flows, proving solar heating is effective and suitable. Future upgrade can improve it further. Thank you very